Standing in the silence of a desert today, it's almost impossible to believe this was once a world of water. The scorching sun, the endless dunes, none of it hints at the vibrant ecosystems that flourished here thousands of years ago. But beneath your feet, hidden under layers of sand, lies evidence of something extraordinary. This barren land was once a thriving oasis, a place where civilizations rose, built, and ultimately vanished as the waters disappeared. What happened to these lost worlds, and what can their stories teach us about our own future? Think about the Sahara, a name that now means emptiness and heat. But long ago, it was a lush green paradise, crisscrossed by rivers and dotted with lakes. Ancient rock paintings show giraffes, elephants, and people fishing, scenes that feel like they belong to another planet. Or consider the deserts of Central Asia, where the Aral Sea once stretched for miles, supporting bustling ports and fishing villages. Today, it's a ghostly expanse of cracked earth. These places weren't just landscapes, they were cradles of human ingenuity, where cultures thrived until the climate turned against them. This isn't just a story about the past, it's a warning, a lesson written in sand and stone. As our own planet faces rising temperatures and shifting weather patterns, these ancient deserts hold urgent secrets. How did societies adapt when their world dried up? Why did some collapse while others found ways to survive? And most importantly, what can we learn from their triumphs and mistakes? Join me as we uncover the mysteries of deserts that once held oceans, piece together the clues left behind by forgotten civilizations, and discover why these echoes from the past matter more than ever. The journey starts now. To understand how flourishing landscapes become deserts, we need to look beyond the surface, literally. Deep beneath the sands lie clues written in layers of earth, telling stories of dramatic change. The process isn't sudden, it's a slow dance between the planet's movements and the atmosphere's whims. Take the Sahara, for instance. Just 6,000 years ago, it was a mosaic of grasslands and shimmering lakes, home to hippos and crocodiles. Then something shifted. Earth's orbit isn't a perfect circle. It wobbles slightly over millennia, altering how sunlight reaches different parts of the globe. These subtle changes, called Milankovitch cycles, can tilt a region toward drought or deluge. Around 5,000 years ago, one such shift caused monsoon rains to retreat southward, starving the Sahara of moisture. But orbit isn't the only culprit. Plate tectonics play a role too. As continents drift, they push mountains skyward, redirecting wind patterns and rain shadows. The rise of the Himalayas, for example, helped dry out Central Asia by blocking moisture-laden air from the Indian Ocean. Then there's the atmosphere itself. Dust storms, once rare, became more frequent as plants died off, exposing soil to the wind. This created a feedback loop. Less vegetation meant more sunlight reflected back into space, cooling the land and further stifling rain clouds. Scientists uncover these clues by studying sediment cores, layers of mud and sand pulled from ancient lake beds. Trapped within them are pollen grains, revealing what plants once grew, and microscopic shells that hint at long-vanished waterways. Even fossilized animal dung tells a story, showing how herds migrated as the land grew parched. But here's what's fascinating: not all deserts formed the same way. The Atacama in South America owes its extreme dryness to cold ocean currents that prevent rain clouds from forming, while the Gobi's expansion was hastened by human activity like overgrazing. These differences matter because they show how fragile the balance is between a thriving ecosystem and a wasteland. And as we stare down our own era of climate change, These ancient processes offer more than just history, they're a blueprint for what might come next. Beneath the shifting sands of Arabia's Rub al-Khali, the empty quarter, lies a secret that defies everything we associate with deserts today. This vast sea of dunes, where temperatures soar past 50 degrees Celsius, was once the floor of an ancient ocean called the Tethys. Millions of years ago, this water stretched across continents, teeming with life. Now, all that remains are ghostly whispers, seashells fossilized in rock, layers of salt crusting the ground like frost, and strange ripples in the earth that only satellites can see. Scientists piece together this hidden history using tools that feel almost like time machines. Satellite imaging reveals patterns invisible to the naked eye, subtle depressions where water once pooled, or mineral deposits that glow like neon signs under infrared light. Ground-penetrating radar sends pulses deep into the earth, bouncing back echoes that paint a picture of buried valleys and ancient shorelines. And then there are the fossils. Tiny ammonites, fish bones, even the teeth of prehistoric sharks, all found miles from the nearest coast, silent witnesses to a world that vanished. But why does this matter? Because these deserts aren't just graveyards of lost oceans, they're archives of Earth's restless nature. The Tethys didn't disappear overnight. It was squeezed out of existence as continents collided, pushing up mountain ranges like the Alps and Himalayas in its place. The same forces that drained these waters also shaped the world we know today. And here's the twist: some of these lost oceans might still be hiding underground. Beneath the Sahara, aquifers hold water that fell as rain thousands of years ago, remnants of wetter ages. What's incredible is how these clues rewrite human history too. Along the edges of these ancient seabeds, civilizations often sprung up where the land was still fertile. The Mesopotamians, for example, built their cities on soil enriched by the same geologic forces that swallowed the Tethys. Their myths even tell of a great flood, echoes perhaps of ancestral memories when the waters still reigned. So when we walk these deserts today, we're not just stepping on sand. We're tracing the edges of forgotten worlds where every grain holds a story of upheaval, adaptation, and the astonishing resilience of life itself. The Garamonte Civilization thrived in what we now call the Sahara Desert, but their story reads like something out of science fiction. Imagine an ancient society carving out a kingdom in one of the most hostile environments on Earth, not by fighting the desert, but by working with it. While most cultures would have withered under the scorching sun, the Garamontes dug deep, literally. Their secret, a sprawling network of underground tunnels called fagaras, designed to tap into hidden reservoirs of water trapped beneath the sand. These weren't just ditches, they were feats of engineering, some stretching for miles, with vertical shafts dug every few yards to allow maintenance and airflow. What's astonishing is how they managed it without modern tools. Using nothing more than bronze and iron picks, the Garamontes mapped out aquifers beneath their feet, channeling water to their fields and cities with precision. Archaeologists have found evidence of orchards, vineyards, and even public baths, luxuries that seem impossible in a landscape now defined by emptiness. Their capital, Garama, was a bustling hub of trade, connecting sub-Saharan Africa with the Mediterranean world. Roman historians wrote about them with a mix of awe and suspicion, calling them the warlike Garamontes who controlled the desert's trade routes. But here's the twist: their greatest strength may have led to their downfall. The fagaras required constant upkeep, and as the climate grew drier, the water tables dropped. Each generation had to dig deeper, and eventually, even their ingenuity couldn't outpace the desert's advance. Soil samples tell a grim story, layers of dust settling over ancient irrigation channels, proof of a slow, suffocating end. Some researchers believe overuse of their limited water sped up the collapse, while others point to broader shifts in trade routes that left them isolated. Either way, their disappearance wasn't sudden. It was a fading, like a mirage dissolving in the heat. Yet their legacy lingers. Modern desert communities in places like Iran and Oman still use versions of the Fagara system, proving how ahead of their time the Garamontes were. And their story forces us to ask uncomfortable questions. What happens when even the most brilliant adaptations aren't enough? How do we balance survival with sustainability? The Sahara's sands may have swallowed their cities, but the lessons they left behind are clearer than ever. As we face our own climate challenges, the Garamontes remind us that no civilization, no matter how advanced, is immune to the whims of nature. Gobekli Tepe rises from the dry plains of southeastern Turkey like a riddle carved in stone. This sprawling complex of massive limestone pillars, arranged in circles and etched with intricate animal reliefs, predates Stonehenge by 6,000 years, and yet it sits in a landscape that today feels utterly inhospitable. How did hunter-gatherers without agriculture or permanent settlements construct something so monumental here? The answer might lie in a climate far different from the one we see now. 12,000 years ago, this region wasn't the sun-baked steppe it is today. Pollen samples from nearby lake beds tell us it was a rolling savanna, rich with wild grasses, gazelles, and freshwater springs. But something shifted. As the last ice age waned, global temperatures rose and rainfall patterns changed. The lush valleys dried up, forcing nomadic groups to cluster around dwindling water sources. Some archaeologists believe Gobekli Tepe was a response to this crisis, a sacred meeting place where scattered tribes gathered to share resources, knowledge, and rituals as their world grew harsher. The carvings on these pillars offer tantalizing hints. Snakes, foxes, and vultures dominate the artwork, but there are also creatures like ducks and cranes which thrive near water. Could these images be memories of a wetter time? Even more intriguing are the depictions of scorpions and spiders, symbols often linked to survival in arid environments. It's as if the builders were documenting their changing world, blending reverence with practicality. And then there's the architecture itself. The T-shaped pillars, some weighing over 10 tons, were quarried from nearby limestone ridges, but transporting them would have required coordinated labor on an unprecedented scale. What if Gobekli Tepe wasn't just a temple, but a kind of ancient innovation hub? One theory suggests the site was a communal project, drawing people together to experiment with new ways of living as traditional hunting grounds vanished. The remains of wild grains found nearby hint at early attempts at cultivation, while the sheer density of animal bones points to feasting, perhaps a way to strengthen social bonds in uncertain times. This challenges the old assumption that agriculture came first, then civilization. Instead, Gobekli Tepe implies that necessity, driven by climate upheaval, sparked both. The most haunting question isn't how they built it, but why they buried it. Around 8,000 years ago, the entire complex was deliberately filled in with rubble, preserving it like a time capsule. Some think it was a ritual act, a farewell to a vanishing way of life as farming took hold. Others suspect the land simply couldn't support such gatherings anymore as the springs dried up. Whatever the reason, Gobekli Tepe stands as a testament to human adaptability, a monument to resilience in the face of a transforming world. Its silent stones urge us to consider how we, too, might respond when the ground shifts beneath our feet. The legend of Ubar sounds like something from a fairy tale, a fabulously wealthy city of towering palaces and bustling markets, suddenly swallowed by the desert as punishment for its greed. For centuries, scholars dismissed it as pure myth, a cautionary tale spun by Bedouin storytellers. But in the 1990s, something extraordinary happened. Satellite images revealed faint geometric patterns beneath the sands of Oman's empty quarter, traces of walls and roads invisible from the ground. When archaeologists dug in, they found not just a settlement, but a sophisticated hub of trade and technology, perfectly positioned along ancient incense routes. This was no ordinary outpost. Ubar thrived at the crossroads of civilizations where caravans carrying frankincense and myrrh, some of the most valuable goods of the ancient world, converged. Its wealth came from controlling the desert's most precious resource, water. The city sat atop a vast limestone cavern, a natural reservoir that allowed it to flourish where others perished. But here's the twist: that same geological gift may have doomed it. Over centuries, the weight of the city's structures and the constant drawing of water weakened the cavern's roof. One day, it simply collapsed, dragging much of Ubar into the earth. Local tales speak of a great sinkhole opening like a mouth, consuming the city in a single night. What makes Ubar's story so haunting isn't just its dramatic fall, but how ordinary its vulnerabilities were. Like modern cities pumping groundwater faster than it can replenish, Ubar's success sowed the seeds of its ruin. Soil samples show that even before the collapse, the land was growing drier, forcing inhabitants to dig deeper wells and rely more heavily on their fragile underground reservoir. And then there's the relentless dunes advancing year by year, burying fields and clogging canals. Sound familiar? Today's deserts are expanding too, with climate change accelerating the process. Yet Ubar's legacy isn't just one of failure. The same satellite technology that uncovered its ruins is now helping archaeologists find other lost cities across Arabia's deserts, revealing a network of settlements that adapted ingeniously to arid conditions. Some built intricate systems of check dams to capture flash floods, while others devised ceramic pipes to minimize evaporation. Their successes and their mistakes offer a blueprint for our own water-starved future. Because the real lesson of Ubar isn't that civilizations fall. It's that they often see the crisis coming, yet keep building right up to the edge of the abyss. Lake Mega Chad was once a titan of freshwater, stretching across what is now Chad, Nigeria, Niger, and Cameroon, with a surface area larger than all of North America's Great Lakes combined. Today, only a fraction remains Lake Chad, a shallow remnant battling for survival. But 12,000 years ago, this was a world of boats and bustling trade, where fishermen cast nets into waters teeming with life, and communities thrived along shores that have long since turned to dust. The scale of this transformation is almost incomprehensible. Satellite images reveal the ghostly outline of the ancient lakebed, a vast depression in the earth where waves once rolled for hundreds of miles. What caused such a monumental shift? The answer lies in a delicate dance between climate and human ingenuity. As the last ice age retreated, the Sahara was a green paradise, nourished by monsoon rains that filled Mega Chad to depths of over 150 meters. But around 5,000 years ago, those rains began to falter. Tree rings and sediment cores tell a story of increasing aridity. As the intertropical convergence zone, the belt of rainfall that circles the equator, drifted southward. The lake shrank rapidly, splintering into smaller bodies of water separated by growing stretches of sand. Yet the people here didn't simply vanish. They adapted in extraordinary ways. Archaeologists have uncovered stone tools and pottery along ancient shorelines, showing how communities shifted from fishing to herding as the waters receded. Rock art in the Tibesti Mountains depicts cattle and giraffes, animals that once grazed on lakeside grasslands. But the most striking evidence comes from the Kanem-Bornu Empire, which rose centuries later in the same region. Their legends speak of a great water their ancestors knew, and their survival depended on ingenious water management, digging wells 30 meters deep and constructing dams to capture seasonal floods. The legacy of Mega Chad's disappearance echoes far beyond its shores. As the lake dwindled, it triggered one of the largest human migrations in history. Groups like the Sao people moved southward, bringing agricultural techniques to the Congo basin, while others pushed east toward the Nile, possibly influencing the rise of ancient Egypt. Even today, the crisis facing modern Lake Chad shrunk by 90% in the last 60 years due to overuse and climate change mirrors the ancient catastrophe. The difference this time, we're not just witnesses to the change, we're the ones holding the balance between survival and collapse. The story of Mega Chad isn't just about what was lost. It's a stark reminder that water, even in the most abundant places, is never truly permanent. High on the sun-baked cliffs of Mesa Verde, the stone towers of the Anasazi cling to the rock like swallows' nests. These intricate dwellings, carved into sheer canyon walls over 700 years ago, are more than just architectural marvels. They're silent witnesses to a civilization that mastered the art of survival in one of North America's harshest landscapes. But by the end of the 13th century, these rooms stood empty. What could drive an entire people to abandon homes they'd built with such care? The answer might lie in something as fragile as a tree's growth ring. Dendrochronology, the science of dating tree rings, has uncovered a chilling clue. By studying ancient timbers from Anasazi ruins, scientists have pieced together a climate record stretching back centuries. The patterns are stark. Between the years 1276 and 1299, the Southwest endured what's now called the Great Drought, a 23-year dry spell so severe it's etched into the wood like a scar. Juniper and ponderosa pines from that era show rings unnervingly thin, some barely visible to the naked eye. These trees weren't just struggling, they were starving for water. But drought alone doesn't explain the Anasazi's fate. These were people who'd thrived for generations in arid country, engineering terraced fields to capture rainfall and storing grain in cleverly designed granaries. Their downfall was likely a cascade of pressures. Tree rings reveal smaller dry spells in the decades before the Great Drought, each one chipping away at their resilience. Then came the final blow, not just lack of rain, but heat. Pollen samples show pinyon forests critical for nuts and fuel dying off as temperatures soared. With crops failing and game scarce, tensions flared. Archaeologists find evidence of violence in this period: burned kivas, hastily built defensive walls. The Anasazi story isn't one of passive surrender, though. As conditions worsened, many likely migrated south, joining Hopi and Zuni communities whose oral histories still speak of ancestors from the north. Others may have dispersed into smaller groups, adapting to a nomadic life. What's haunting is how closely their crisis mirrors our own Southwest today, where mega-droughts and overused rivers strain modern cities. The difference: the Anasazi didn't see it coming. We have their ruins and those tree rings as a warning. The Indus Valley civilization was a marvel of urban planning, with streets laid out in perfect grids and homes equipped with some of the world's earliest indoor plumbing. This wasn't just convenience, it was a testament to their mastery over water in a region where every drop mattered. Yet by 1900 BCE, their great cities like Mohenjo-Daro and Harappa lay abandoned, their carefully laid bricks crumbling into dust. What could topple a society so advanced? The answer might be written in layers of mud at the bottom of the Arabian Sea. sediment cores drilled from the ocean floor near the Indus Delta tell a startling story. Mixed within the silt are tiny shells of plankton that thrive in specific water conditions, along with pollen grains from long-vanished plants. Together, they paint a picture of a climate in flux. Around the time the cities fell, monsoon rains, the lifeblood of the Indus region, began to fail. The weakening rains weren't just a bad season or two, they were part of a centuries-long shift. Scientists call it the 4.2-kilo-year event, a global drought that toppled empires from Egypt to Mesopotamia. But for the Indus people, it wasn't just about less rain, it was about timing. Their entire agricultural system relied on predictable floods to replenish fields along the riverbanks. As monsoons grew erratic, the Indus River itself changed course, leaving canals dry and harvests stunted. Archaeologists find evidence of desperate adaptations. Wells dug deeper, grain storage rooms expanded. Yet even their famed water management couldn't outlast the environmental chaos. Here's the twist: some cities declined while others thrived. Recent studies suggest certain settlements to the east, where rainfall patterns held longer, actually grew as people migrated. This wasn't a uniform collapse, it was a slow unraveling, a society reorganizing itself under mounting pressure. The parallels to today are impossible to ignore. Modern Pakistan, home to the same rivers that sustained the Indus people, now faces severe water stress due to overuse and shifting monsoons. Like their ancient counterparts, farmers today rely on fragile irrigation systems, while underground aquifers, some holding water thousands of years old, are pumped dry. The difference: we have satellites to track rainfall and dams to control floods. Yet the core challenge remains the same: how to share a dwindling resource fairly among millions. The Indus civilization's legacy isn't just in their ruins, it's in the warning they left behind. When water systems fail, even the mightiest cities can fade into legend. Petra emerges from Jordan's desert like a mirage carved in stone, its rose-colored cliffs hiding a secret that made this city possible: water. In a land where rainfall is as rare as a cool breeze, the Nabateans didn't just survive, they thrived, turning their capital into a glittering hub of trade and culture. Their genius lay in harnessing every drop. Elaborate systems of dams, cisterns, and channels snaked through the mountains, capturing flash floods and directing them into reservoirs so precise they lost barely any water to evaporation. One tunnel, the Sikh Aqueduct, carved through solid rock for over a kilometer, delivered water directly to the city's heart. This wasn't just infrastructure, it was alchemy, transforming desert into abundance. Yet even the Nabateans couldn't defy the climate forever. Tree rings from ancient junipers tell a troubling story. Around the 1st century CE, the region entered a prolonged dry spell, with rainfall dwindling to a fraction of what Petra's systems were designed to handle. Sediment cores from the Dead Sea, just 50 miles away, reveal layers of dust from this era, proof of eroding topsoil as vegetation died off. The Nabateans adapted, digging deeper channels and rationing water, but their trade networks began to fray. Caravans that once brought wealth now faced sand-choked routes and dwindling oases. Then came the final blow, a massive earthquake in 363 CE that shattered their intricate waterworks. What's haunting is how modern Petra mirrors these ancient struggles. Today, climate change is drying up the region again, with droughts more frequent and severe. Flash floods, once carefully harnessed by the Nabateans, now tear through the site, damaging monuments unprotected by vanished dams. But there's hope in their legacy. Archaeologists studying Petra's water systems have uncovered techniques we're rediscovering today, like water harvesting, where ancient channels fed gardens in otherwise barren land. In Jordan's modern cities, engineers are reviving these methods to combat water scarcity. The Nabateans didn't just leave behind ruins, they left a blueprint for resilience, proving that even in the harshest places, ingenuity can bloom if we're willing to learn from the past. The Aral Sea was once the fourth largest lake in the world, a shimmering expanse of blue between Kazakhstan and Uzbekistan, so vast it moderated the region's climate. But in just 50 years, it shrank to less than 10% of its original size, a collapse so rapid you can watch it happen in satellite images, like watching a bathtub drain in fast forward. The culprit, ambitious Soviet irrigation projects of the 1960s that diverted rivers feeding the sea to water cotton fields in the desert. It wasn't just a policy failure, it was a real-time experiment in how quickly human decisions can unravel an ecosystem. This modern disaster holds eerie parallels to ancient desertification, just like the Garamontes tapping aquifers until they ran dry, or the Ubarites overdrawing their limestone cavern. The Soviet engineers treated water as infinite. They transformed the Amu Darya and Sadaria rivers into a labyrinth of canals, creating a cotton boom that turned the region into one of the world's top producers. But the cost was staggering. As the rivers dwindled, the Aral Sea's salinity spiked, killing off fish species that had sustained local communities for centuries. Winds picked up toxic dust from the exposed seabed laced with pesticides from the cotton farms and spread it across villages, causing epidemics of respiratory diseases and cancers. What's chilling is how closely this mirrors past civilization's tipping points. Sediment cores from the Aral's dried stretches show layers of shells suddenly vanishing, just like those found in the ruins of Mesopotamia's collapsed irrigation systems. The difference is speed. Where ancient societies took centuries to exhaust their resources, the Aral disaster unfolded within a single lifetime. Yet the warning signs were identical: dropping water tables, salt crusting over farmlands, and a stubborn insistence that technology could outpace nature. The tragedy isn't just ecological, it's cultural. The Aral's fishing towns, once lively ports, now sit stranded in a desert of cracked earth, their boats rusting miles from any water. It's a scene straight from the Sahara's abandoned oases or the ruins of Mohenjo-Daro. But here's the twist: unlike those ancient collapses, we have satellite data, climate models, and historical hindsight. We know exactly how this story goes. Yet today, similar mega irrigation projects continue in places like California's Central Valley and India's Punjab, pumping groundwater faster than rain can replenish it. The Aral Sea's legacy isn't just a cautionary tale. In the northern section, a dam built in 2005 has partially restored the water, proving that even drastic damage can sometimes be reversed. Fish have returned to pockets of the sea, and microclimates are slowly recovering, but the larger lesson lingers. When we ignore the limits of water, whether in ancient Petra or modern Kazakhstan, the desert always wins. The Aral didn't just vanish, it left behind a question: will we finally learn from history, or keep repeating its mistakes until our own cities are the next ruins in the sand? Satellite archaeology has turned the desert's silent surface into a living map of forgotten worlds. Imagine flying over the Sahara, not with the naked eye, but with sensors that peer straight through layers of sand to uncover the bones of lost cities. This isn't science fiction, it's LiDAR, short for light detection and ranging, a technology that fires laser pulses from aircraft and measures their reflection to create precise 3D models of the ground below. In places like Sudan's ancient Nubian region, LiDAR has revealed sprawling urban grids buried for centuries, complete with streets, temples, and even irrigation canals. These weren't just small settlements, they were metropolises rivaling medieval European capitals, thriving in what's now a sea of dunes. But LiDAR isn't the only tool rewriting history. Thermal imaging satellites, originally designed for military surveillance, have become unexpected allies in the hunt for vanished civilizations. By detecting subtle temperature differences in the soil, cooler where stone foundations lie, warmer where loose sand dominates, these sensors can outline entire cities without a single shovel touching the ground. In the deserts of Central Asia, thermal scans exposed the footprint of the Sogdian Empire, a Silk Road powerhouse whose trade networks once stretched from China to Persia. The images showed something astonishing: a grid of streets aligned not with modern roads but with long-dried riverbeds, proving how tightly these cities were tied to vanished waterways. Then there's multispectral imaging, a technique that goes beyond visible light to analyze how the Earth reflects different wavelengths. In the Arabian Peninsula, this technology has spotted ancient kites, massive stone structures used to funnel wild animals into traps built by hunter-gatherers over 8,000 years ago. More remarkably, multispectral data can reveal long-lost agricultural fields by detecting traces of organic matter or minerals like phosphorus, which accumulate where humans once farmed. Near Egypt's Fayoum oasis, these scans uncovered checkerboard patterns of ancient plots, still visible in the soil chemistry millennia after the last harvest. What makes these tools revolutionary isn't just their ability to find ruins, it's how they connect them to climate history. By mapping ancient river channels now buried under sand, scientists can reconstruct rainfall patterns that sustained civilizations. In Mauritania, radar satellites penetrated the desert to expose the remains of the Tichit culture, a society that thrived 4,000 years ago along a network of now vanished lakes. The layout of their stone villages, clustered along what were once shorelines, tells a story of gradual retreat as the waters evaporated. Each abandoned ring of houses marks another step inland, another generation forced to adapt. The real power of satellite archaeology lies in its scale. Ground surveys might uncover a single site, but satellites can scan thousands of square miles in days, revealing patterns invisible to those standing in the dust. For example, in the Indus Valley, orbital imagery exposed hundreds of previously unknown settlements along the Gagga-Hakra River, a waterway once thought mythical. These finds didn't just expand the map of the civilization, they proved its heartland was farther east than assumed, in a region now too dry to support large populations. Suddenly, the Indus people's collapse makes more sense. Their cities didn't just fail, they were built on a climate time bomb, dependent on rivers that were already fading when the first bricks were laid. Perhaps the most poignant discoveries are the ones that defy expectations. In Peru's Nazca Desert, famous for its giant geoglyphs, satellite surveys revealed something unexpected: intricate networks of underground aqueducts called puquillos, built to tap into subsurface water. For years, scholars debated their age, some arguing they were colonial-era constructions. But satellite data showed they aligned perfectly with pre-Hispanic settlements, proving the Nazca people engineered solutions to drought long before modern pumps existed. Their ingenuity, hidden in plain sight, reminds us that the past isn't just a graveyard of failures, it's also a treasure chest of forgotten wisdom. As these technologies evolve, they're doing more than uncovering lost cities. They're reshaping our understanding of human resilience. Every buried wall, every ghostly river channel, tells a story of adaptation of societies that flourished until the environment shifted beneath them. And in a world facing its own climate upheaval, these ancient blueprints, now visible from space, might hold the keys to our survival. The desert's secrets, once locked in sand, are finally coming to light, not through shovels but through the silent gaze of satellites orbiting high above. Beneath the cracked surface of the Sahara, hidden channels snake through the earth like the veins of a sleeping giant. These fossilized rivers, long since choked with sand, are the ghosts of ancient waterways that once turned deserts into gardens. Finding them isn't just about geology, it's detective work, piecing together clues from satellite images, radar scans, and even the whisper-thin layers of sediment left behind. Take the Tamanrasset River, for example, stretching nearly 500 kilometers across what's now Algeria and Mauritania. It was once a roaring tributary feeding into the Atlantic. Today, its path is invisible unless you know where to look. Geologists trace these vanished rivers using tools that feel almost magical. Gravity-sensing satellites orbit high above, detecting subtle dips in Earth's gravitational field where denser riverbed sediments still linger underground. Then there's ground-penetrating radar, sending pulses into the Earth that bounce back with echoes of buried gravel banks and clay deposits, the telltale fingerprints of flowing water. But some of the most revealing evidence comes from the humblest sources: fossilized freshwater mollusks, their delicate shells mixed into dunes, or the rounded pebbles scattered far from any modern stream. These stones didn't get here by chance. They were tumbled smooth by currents that vanished millennia ago. What's astonishing is how these dead rivers rewrite human history. Along the Wadi Hawar in Sudan, archaeologists have uncovered stone tools and pottery shards lining what was once a lush riverbank. This wasn't just a watering hole, it was a highway. Known as the Yellow Nile, this ancient tributary connected the African interior to the Nile Valley, allowing cultures to trade goods and ideas across vast distances. When the river dried up around 4,000 years ago, the entire region's power structure shifted, with settlements clustering closer to the surviving Nile. Similar stories echo in Arabia's Wadi Batin, where Paleolithic hand axes lie buried in river gravels beneath the sand, proof that early humans thrived here when the land was green. The real revelation lies in how these rivers didn't just disappear, they migrated. Core samples from the Arabian Peninsula show something startling: layers of sediment revealing cycles of wet and dry periods, each lasting centuries. During humid phases, rivers like the now-buried Wadi ad-Dawasir carved canyons through the desert, only to vanish when aridity returned. Civilizations followed these shifting waters like actors on a stage, their cities rising and falling with the climate's rhythm. The ruins of Qaryat al-Faw, a once prosperous trading hub in Saudi Arabia, sit stranded in dunes, but satellite imagery reveals its secret. It was built atop an ancient river delta, a final holdout as the land dried. Perhaps no place illustrates this dance between water and civilization better than the Ghaggar Hakra in India and Pakistan. Once thought to be a mythical river from Vedic texts, satellite surveys proved it was real, a massive waterway that paralleled the Indus. When the Ghaggar Hakra's flow began to falter around 2600 BCE, its cities didn't empty overnight. Instead, they adapted, digging wells deeper and shifting crops to drought-resistant millet. But as the river's final branches withered, even these measures failed. The lesson here isn't just about loss, it's about the ingenuity sparked by scarcity. These fossilized rivers aren't just relics, they're roadmaps, showing how civilizations navigate the slow-motion crisis of a changing world. And as modern aquifers drain and rivers shrink, their stories feel less like ancient history and more like a mirror. Monsoons have been the lifeblood of civilizations for millennia, until they become their undoing. Picture the Khmer Empire at its height, its capital Angkor sprawling across the Cambodian jungle, a masterpiece of canals and reservoirs designed to capture every drop of seasonal rain. For centuries, this system worked flawlessly, but then the monsoon stuttered. Tree rings from ancient cypress trees tell the story. Between the 14th and 15th centuries, the region suffered decades of erratic rainfall, swinging from brutal droughts to catastrophic floods. The Khmer's intricate water network, once their greatest strength, became a liability. Canals silted up during dry spells, then overflowed in deluges, drowning fields and destabilizing the very foundations of their temples. The empire didn't fall overnight, it unraveled as farmers abandoned the hinterlands and power fragmented. Half a world away, the Maya faced a similar reckoning. Their cities, like Tikal and Calakmul, were engineered around seasonal rains, with vast reservoirs carved into limestone to tide them over during dry months. But sediment cores from Lake Chichankanab reveal a grim truth. The 9th century brought a series of megadroughts, some lasting over a decade. The Maya adapted at first, shortening crop cycles, trading for food, but their societal structure relied on kings who claimed divine control over the rains. When the skies refused to comply, faith in their rulers crumbled faster than the soil. The collapse wasn't uniform. Some cities in wetter northern regions survived longer, while others in the south were swallowed by the jungle within generations. What makes these stories so chilling is the pattern. In India, the decline of the Gupta Empire coincided with weakened monsoons around the 6th century, while the Tang dynasty in China faltered as rains shifted southward. These weren't isolated events, they were dominoes falling across continents, all tied to the same atmospheric dance. Scientists now recognize the culprit, the intertropical convergence zone, the band of rain giving clouds that circles the equator. When it wobbles due to ocean temperature shifts or volcanic eruptions, civilizations built on its predictability pay the price. But here's the twist: some societies found ways to endure. The people of Vijayanagara in southern India constructed massive tanks to store monsoon rains, while the ancestral pueblones of the American Southwest developed drought-resistant crops like tepary beans. Their successes highlight a crucial lesson: it's not just the climate that dictates survival, but the flexibility of human response. Today, as modern megacities from Mumbai to Manila grapple with increasingly erratic monsoons, these ancient collapses aren't just history. They're a test, one we're still learning how to pass. Long before scientists studied tree rings or sediment cores, our ancestors encoded their encounters with drought in stories passed down through generations. Take the biblical tale of Joseph interpreting Pharaoh's dream: 7 fat cows devoured by 7 gaunt ones, foreshadowing years of plenty followed by famine. This wasn't just allegory. Modern climate reconstructions reveal that around 1600 BCE, Egypt faced a prolonged dry spell that likely disrupted Nile floods, the lifeblood of its agriculture. The story survives not as fiction, but as a survival manual dressed in metaphor, teaching future rulers to store grain against inevitable scarcity. Indigenous cultures wove similar wisdom into their oral traditions. The Hopi speak of a time when rains failed, and their ancestors scattered across the land in search of water, a memory that aligns with archaeological evidence of drought-driven migrations in the American Southwest around 1200 CE. Their legends describe the Kachinas, spirit beings who withheld rain to punish greed, urging balance with nature. Halfway across the world, Aboriginal Australians tell of the rainbow serpent, a creator deity whose movements shaped rivers and waterholes. During droughts, ceremonies reenact its journey, a ritual plea for the serpent to return and replenish the land. These aren't mere myths, they're time capsules of ecological trauma, preserving hard-won lessons in allegorical form. Even tales we dismiss as fantasy hold hidden truths. The Greek myth of Phaethon, who lost control of the sun chariot and scorched the earth, mirrors real events. Ice cores from Greenland show a sudden spike in temperatures around 3200 BCE. possibly caused by a volcanic eruption or solar flare. The resulting drought left its mark from Mesopotamia to the Nile, reshaping societies. Likewise, the Mesopotamian epic of Gilgamesh includes a flood story, but less known is its reference to a 7-year drought that preceded it, a detail corroborated by sediment layers in the Persian Gulf. What makes these stories so powerful isn't just their accuracy, but their purpose. Unlike modern climate data, which lives in academic journals, myths were designed to stick. They turned abstract weather patterns into vivid dramas, gods angered by human arrogance, spirits testing communal resilience. The Kalahari Bushmen's tales of the trickster god Kagan withholding rain until people shared resources weren't entertainment. They were social governance, enforcing cooperation in harsh environments. Today, as we grapple with climate change, we've lost something vital: the art of embedding survival lessons in stories that outlast libraries. Our ancestors didn't just remember the droughts, they made sure no generation would forget. The Sahara wasn't always a sea of sand. In fact, it's flipped between lush greenery and barren desert like a cosmic switch being flicked every 20,000 years. This isn't just speculation, it's written in the earth itself. Deep beneath the dunes, sediment cores tell a story of dramatic back and forth. Layers of pollen from ancient grasslands sandwiched between dust, like pages in a book no one opened for millennia. The last green Sahara phase peaked around 6,000 years ago, a time when hippos wallowed in lakes that stretched for hundreds of miles and nomadic herders painted vivid scenes of giraffes and elephants on cave walls. But what forces could possibly turn the world's largest hot desert into a savanna and back again? The answer lies in a celestial dance few of us ever notice. Earth's orbit isn't static. It wobbles slightly over eons, changing how sunlight is distributed across the planet. These shifts, called Milankovitch cycles, nudge the monsoon belt northward or southward like a wandering rain belt. When the tilt of Earth's axis aligns just right, the Sahara soaks up summer rains that today fall hundreds of miles to the south. The transformation isn't gradual. Climate models suggest it can happen in just centuries, a blink in geologic time. And here's the twist: we're due for another shift. Based on orbital patterns, the Sahara should start greening again in about 15,000 years. But human activity might be rewriting that timetable. The real question isn't just when the Sahara could turn green, it's how. Modern climate change is altering the equation. Some studies suggest rising global temperatures could intensify West African monsoons, potentially speeding up the process. Satellite data already shows patches of vegetation expanding along the Sahara's southern edge, a phenomenon scientists call the Sahel greening. But there's a catch. This isn't the same as the natural cycles of the past. Pumping too much carbon into the atmosphere could destabilize rainfall patterns, turning some regions wetter while others dry out completely. The Sahara might not transition smoothly. It could lurch unpredictably between extremes, leaving ecosystems and the people who depend on them struggling to adapt. What does this mean for the future? If history is any guide, a greener Sahara would reshape human civilization all over again. During past wet phases, the region was a highway for migration, connecting sub-Saharan Africa to the Mediterranean. Ancient river systems like the Tamanrasset could reactivate, creating corridors for trade and travel where there's now only emptiness. But there's a darker side. The same rains that revived the Sahara might starve other regions. Monsoons are a balancing act. If they shift north, places like India or Southeast Asia could face devastating droughts. It's a reminder that the planet's climate is a web, and tugging one thread can unravel societies thousands of miles away. The Sahara's cycles hold a mirror to our own era of climate upheaval. Past shifts happened without factories or cars, driven solely by nature's rhythms. Now, for the first time, a species holds the levers, not just to witness the change, but to influence it. Whether that's a warning or an opportunity depends on what we do next. The desert sands are still moving, not just with the wind, but with the echoes of changes yet to come. Oases shimmer in the desert like mirages made real, but their impact stretches far beyond a handful of palm trees and a spring. These rare water sources were the beating hearts of entire civilizations, the secret fuel behind sprawling trade networks that connected continents. Take Siwa Oasis in Egypt, a lush island in the Libyan desert where Alexander the Great famously sought guidance from the Oracle of Ammon. Its natural springs didn't just quench thirst, they anchored a crossroads of cultures where Berber, Greek, and Egyptian traders exchanged goods and ideas under the shade of date palms. The oasis was so vital that its water rights were fiercely guarded. Ancient inscriptions reveal disputes over access settled by royal decree, proving that control of water meant control of power. Yet not all oases enjoyed Siwa's staying power. The lost oasis of Zazura, whispered about in medieval Arab texts as a white city hidden somewhere in the Sahara, lured explorers for centuries. Some believe it was Tafilalt in Morocco, once a thriving hub for salt and gold caravans until its springs dried up in the 17th century. Others point to satellite images of ghostly river channels beneath Libya's dunes, hinting at settlements swallowed by sand. The difference between survival and oblivion often came down to geology. Oases fed by deep aquifers like Morocco's Tinahir could outlast droughts, while those dependent on fragile surface water vanished when the climate turned. The political chessboard of the ancient world was shaped by these watery dots on the map. The Romans fortified oases like Ghadames in Libya as military outposts, while the Silk Road's most lucrative stops, Samarkand, Bukhara, rose around artesian wells. When the Mongols destroyed the Khanate systems sustaining Persia's oases in the 13th century, they didn't just burn cities, they unraveled a web of trade that took centuries to rebuild. Even the Bible's Sodom and Gomorrah, if they existed, may have been oasis cities whose downfall was tied to tectonic shifts disrupting their water supply. Today, the fate of oases mirrors the pressures of the past. In China's Tarim Basin, overpumping for cotton farms has drained aquifers that sustained Dunhuang's oasis for millennia, leaving its famous crescent moon spring reliant on artificial replenishment. Meanwhile, Morocco's Skoura oasis thrives by blending ancient irrigation techniques with solar-powered wells, proving adaptation is possible. These patches of green aren't just relics. They're living classrooms, teaching us how to balance human ambition with nature's limits. The next time you see a palm-fringed pool in the desert, remember, it's not just water in the sand. It's the legacy of every society that ever gambled on its survival. The Silk Road wasn't just a path across the desert. It was a lifeline strung between oases, each one a fragile guarantee of survival in a merciless landscape. Picture a caravan of camels laden with spices and silk, their route dictated not by the shortest distance, but by the locations of wells and springs that might vanish within a generation. These water sources were the invisible puppeteers of history, determining which cities thrived as cosmopolitan hubs and which crumbled into oblivion. Take Lulan, a bustling oasis kingdom on the edge of China's Taklamakan Desert. 1,000 years ago, it was a pit stop for merchants traveling between the east and west, its streets alive with the chatter of Sogdian traders and the clink of Persian silver. Then the Tarim River shifted course and Lulan's wells turned to dust. Today, its mud-brick ruins stand encircled by dunes, a ghost town where the wind whistles through empty doorways. But Lulan's fate wasn't unique. Along the Silk Road's northern branch, the ancient city of Merv in modern-day Turkmenistan once rivaled Baghdad in splendor, its gardens fed by the Murgab River. When Mongol invaders destroyed its irrigation canals in the 13th century, the damage was catastrophic, but it was the slow death of the river, choked by silt and dwindling rains, that sealed Merv's fate. Further west, Palmyra's towering arches rose from the Syrian desert thanks to an ingenious system of underground aqueducts called qanats. When Roman engineers neglected these tunnels during political upheavals, the water stopped flowing and Palmyra's grandeur faded into a mirage. What's startling is how these collapses ripple through time. As key oases dried up, entire routes were rerouted. The southern Silk Road, which ran through the Fergana Valley, grew dominant when the northern path became too perilous, not because of bandits, but because the wells had disappeared. Satellite images reveal the scars of these shifts, faint tracks in the desert where caravans once walked, leading to vanished waterholes. Even the legendary city of Samarkand owes its prominence to geography. Its location at the confluence of two rivers made it a fail-safe hub when other routes succumbed to drought. The lesson here isn't just about the past. Today, the same patterns are replaying along modern trade corridors. In Central Asia, the shrinking of the Aral Sea has forced cargo ships to abandon ports that were thriving just 50 years ago. Along China's Belt and Road Initiative, engineers grapple with sinking water tables in Pakistan's Gwadar region, mirroring the crises that toppled Silk Road cities. The difference is scale. Where ancient traders had the flexibility to shift routes, our globalized economy depends on fixed infrastructure. When a highway or rail line is built on assumptions of stable water, its fate may already be written in the sand. Yet hidden in these stories are glimpses of resilience. The Silk Road didn't vanish when one oasis failed. It adapted, finding new paths where water persisted. In Uzbekistan's Kizilkum Desert, archaeologists have uncovered caravanserais built atop ancient glacial melt channels, proof that merchants tracked water as meticulously as any modern hydrologist. Perhaps that's the ultimate takeaway. Commerce, like civilization itself, is a dance with the environment. The next time you see a map of trade routes, look for the invisible lines, the rivers that aren't there anymore, the wells that once were. They're the silent architects of history, reminding us that every empire, no matter how grand, rests on something as simple as a drink of water. Deep in the caves of Oman's Hajar Mountains, stone pillars rise from the floor like silent sentinels guarding Earth's oldest secrets. These stalagmites, formed drop by drop over thousands of years, are nature's own climate diaries, their layers encoding precise records of rainfall, drought, and temperature shifts. To scientists, they're more than geological formations, they're time machines. By drilling tiny cores from these mineral columns and analyzing the chemical fingerprints trapped inside, researchers can reconstruct ancient weather patterns with astonishing accuracy. The process hinges on something invisible to the naked eye: our oxygen isotopes. Rainwater carries distinct isotopic signatures depending on global climate conditions. During wet periods, heavier oxygen isotopes dominate, while droughts leave behind lighter variants. As each droplet seeps through the cave ceiling and deposits its minerals, it locks these clues into the growing stalagmite. Using lasers to vaporize microscopic samples, scientists measure these isotopes layer by layer, like reading tree rings but with far greater precision. One stalagmite from Hoti Cave revealed a 900-year drought that ravaged Arabia around 5,200 years ago, a catastrophe that likely scattered early Bronze Age settlements. Other caves in Yemen have chronicled monsoon failures that align with the collapse of the Sabaean kingdom, famed for its towering dams. But stalagmites don't just record rainfall, they capture temperature too. Trace elements like magnesium and strontium seep into the stone at rates tied to heat and humidity. In Oman's caves, spikes in these elements correspond to abrupt warming events documented in Greenland ice cores, proving how interconnected Earth's climate systems are. The real breakthrough came when scientists matched these cave records with archaeological findings. A stalagmite from Qunf Cave showed a sudden shift to drier conditions around 2200 BCE, the exact period when the Akkadian Empire crumbled amid crop failures and mass migrations. What makes these cave archives revolutionary is their global reach. While ice cores are limited to polar regions and tree rings to temperate zones, stalagmites thrive in deserts worldwide. New Mexico's Carlsbad Caverns have unveiled megadroughts that parched the ancestral pueblones, while Chinese caves near the Silk Road track the monsoon failures that starved dynasties. Even more remarkable is their resolution. Some stalagmites grow fast enough to record seasonal changes, offering snapshots of ancient summers and winters. The urgency of this research couldn't be clearer. As modern climate models struggle to predict future rainfall patterns, caves offer hard data on how Earth behaved during past extremes. A stalagmite from southern Australia revealed a 400-year dry spell that began abruptly, a warning that today's droughts could intensify faster than we anticipate. Meanwhile, caves beneath the Atacama Desert, the driest place on Earth, hold evidence of hyper-arid periods lasting millennia, proving how drastically climates can shift. These stone sentinels remind us that deserts weren't always barren and fertile lands weren't always safe. The same forces that turned the Sahara to dust or emptied Central Asia's rivers could reshape our world again. But this time, we're not just deciphering the past from cave walls, we're writing the next chapter ourselves. Timbuktu's golden age gleamed like a mirage in the Sahara, a city where scholars penned thousands of manuscripts in ink made from crushed acacia pods, where the streets hummed with debates about astronomy and law, and where the Niger River's lifeblood sustained a metropolis of learning in the heart of the desert. By the 16th century, it was a beacon of the Islamic world, its libraries rivaling those of Baghdad and Constantinople. Yet within a few hundred years, its glory had faded, its libraries abandoned to the dust, its streets swallowed by sand. What transformed this intellectual oasis into a shadow of itself? The answer lies in the shifting dance between the Niger River and the hands that tried to control it. The Niger was Timbuktu's lifeline, its annual floods depositing fertile silt that fed crops and replenished wells. But rivers are restless things. Sediment cores from the Niger Delta reveal a pattern of gradual migration channels silting up, banks eroding, and waters finding new paths. Some shifts were natural, part of the river's ancient rhythm. Others were hastened by human hands. As Timbuktu grew, its demand for water strained the system. Canals dug to irrigate fields diverted the river's flow, while deforestation upstream left soils loose and vulnerable to erosion. By the time Portuguese explorers reached the city in the 18th century, they described a place already in decline, its once bustling ports stranded miles from the water's edge. Yet blaming the river alone misses a crucial layer. Timbuktu's unraveling was as much about politics as hydrology. The city's wealth had always depended on trade: gold from the south, salt from the Sahara, and books that traveled farther than the camels carrying them. When Moroccan invaders sacked the city in 1591, they disrupted these networks, scattering scholars and cutting ties with tributary states that maintained the region's waterworks. Without the taxes and labor these alliances provided, canals clogged and floodplains dried. The very knowledge that had made Timbuktu great, the meticulous records of flood cycles and crop rotations was lost as libraries were looted or left to rot. Climate, too, played its part. Ice cores from Mount Kilimanjaro show West Africa entered a drier phase around the same period, with monsoon rains growing erratic. The Niger's floods, once as reliable as the seasons, became unpredictable. Farmers who had relied on the river's bounty found their fields either parched or drowned, with no middle ground. In a cruel twist, some of Timbuktu's own innovations may have backfired. The same earthworks that once controlled flooding now trapped salt during droughts, poisoning the soil. Archaeologists have found layers of white crust in abandoned fields, the telltale mark of land pushed past its limits. Today, Timbuktu stands as a monument to fragility. Efforts to restore its manuscripts and monuments are underway, but the Niger's waters continue to retreat, now pressured by modern dams and rising temperatures. The city's story forces us to ask, was its decline inevitable, or did missteps turn a challenge into a catastrophe? Perhaps the lesson isn't just about water, but about what happens when a society's survival depends on systems it doesn't fully control. Timbuktu's scholars once wrote of the delicate balance between heaven and earth. Their city's ruins remind us how easily that balance can be lost. Bones don't lie, especially when they're scattered across landscapes that once pulsed with life. In the dried-out basins of Africa's Chalbai Desert, paleontologists have uncovered a graveyard of giants, hippopotamus skulls half buried in sand, giraffe femurs polished by centuries of wind, and crocodile vertebrae lying miles from the nearest river. These aren't random relics, they're waypoints in an ancient evacuation, markers of a time when entire ecosystems packed up and left as the water vanished. The story written in these bones isn't just about animals, it's a survival blueprint our ancestors may have followed. Take the wildebeest, those iconic migrants of the Serengeti. Their modern-day treks are legendary, but fossil evidence shows their ancestors once roamed much farther north, in what's now the Sahara. As the land dried 6,000 years ago, their migration routes stretched longer and longer, until only the hardiest herds reached the savannas we know today. Zebras followed similar paths, their striped hides evolving as camouflage for the new grasslands they entered. Even predators like lions shifted territories, their fossils appearing suddenly in regions previously dominated by desert-adapted species like cheetahs. This wasn't an orderly retreat, it was a chaotic reshuffling of life, with winners and losers carved by climate's whim. Humans were part of this exodus. Alongside animal bones, archaeologists find stone tools and hearths tracing our species' own slow migration out of desiccating regions. At Gobero in Niger, a site that was once a lakeside paradise, graves hold the remains of tall, Kiffian hunters alongside later Tenerian herders, two cultures separated by centuries of drying climate. The Kiffians thrived on fish and game, their harpoons still littering the ancient shore. But as the lake shrank, the Tenerians arrived with cattle, adapting to a harsher world. Their secret mobility. While the Kiffians had built semi-permanent settlements, the Tenerians lived light, following seasonal pastures like the wildebeest they now competed with. The most startling clues come from isotopes locked in tooth enamel. By analyzing oxygen and strontium ratios, scientists can reconstruct an animal's or a human's lifetime travels. A hippo tusk from the now barren Jorab Desert in Chad reveals its owner drank from rivers that flowed year-round, while cattle teeth from the same area show their herds were driven hundreds of miles to find water. Human remains tell parallel stories. A child buried in Kenya's Turkana Basin with teeth marking its mother's migration from the drying Sahara, or a Neolithic trader whose molars record repeated treks between oases that no longer exist. These aren't just individual journeys, they're fragments of a vast, unrecorded epic of climate refugees. What does this mean for us? Modern satellite tracking of elephant herds in Namibia mirrors these ancient patterns. During droughts, matriarchs lead their families along routes passed down through generations, routes that often align with fossilized game trails. Indigenous pastoralists like the Himba still navigate using ancestral knowledge of long-vanished waterholes, their oral maps overlapping with paleontological finds. The difference is scale. Where prehistoric species had millennia to adapt, today's climate shifts unfold in decades, leaving no time for evolution to carve new paths. The bones of the past whisper a warning: when the land changes, the rules change. Survival favors those who read the signs early and aren't afraid to move. Beneath the sun-scorched plains of Iran, a hidden network of tunnels snakes through the earth like the roots of some ancient, invisible tree. These are Qanat's ingenious subterranean channels that have carried life-giving water to desert settlements for over 3,000 years. Picture this: a gently sloping tunnel, hand-dug through layers of rock and soil, tapping into a distant mountain aquifer and guiding the water downhill purely by gravity. The brilliance lies in its simplicity. At regular intervals, vertical shafts plunge from the surface like chimneys, providing airflow and access for maintenance while minimizing evaporation under the relentless desert sun. Some Qanats stretch for 50 miles, their construction requiring generations of communal effort, a testament to human cooperation in the face of scarcity. One of the most astonishing examples wins beneath the city of Garamonte, where a Qanat system dating back to the Achaemenid Empire still supplies water today. Its main tunnel, carved through solid rock at a precise gradient, delivers crystal-clear water to orchards that bloom improbably in the surrounding dust. The builders didn't just dig randomly, they followed subtle clues like damp soil patches or certain vegetation patterns to locate underground streams. Their knowledge was so precise that modern hydrologists using satellite imaging often confirm the exact routes these ancient engineers chose. Cross the Sahara to Algeria's Mzab Valley, and you'll find a similar marvel, the Fagaras. While sharing the Qanat's basic principle, these systems reveal unique adaptations to harsher conditions. Here, the tunnels often begin beneath dry riverbeds where seasonal floods briefly recharge underground reserves. The Garamontes we discussed earlier perfected this technique, but Berber communities refined it further, adding filtration systems using layers of gravel and sand to purify the water as it traveled. In the oasis of Timmermound, Fagaras branch like capillaries beneath the palm groves, each family maintaining their section with rituals passed down since medieval times. During droughts, councils of elders redistribute water based on ancient fairness protocols, a democratic approach to survival in the desert. What makes these systems extraordinary isn't just their engineering, but their social impact. Qanats and Fagaras became the backbone of entire civilizations, enabling cities like Yazd in Iran to flourish as centers of culture and trade in otherwise uninhabitable landscapes. The water wasn't merely for drinking, it powered mills, filled public baths, and sustained elaborate gardens that cooled entire neighborhoods through evaporation. Persian poets wrote verses comparing Qanats to veins nourishing the body of the earth, while legal texts detailed meticulous water-sharing laws that prevented conflicts. Yet these watery lifelines faced constant threats. Earthquakes could collapse tunnels, while invading armies often sabotaged Qanats to besiege cities. The most insidious enemy, though, was complacency. In Morocco's Tafilalt region, abandoned Fagara shafts tell a cautionary tale. As modern wells with electric pumps arrived in the 1970s, communities neglected their ancient tunnels. The result, water tables dropped, turning once fertile oases into cracked earth. Now, some villages are relearning old maintenance techniques, realizing technology alone can't replace sustainable traditions. The true legacy of Kannats and Fogaras lies in their philosophy. They represent a dialogue with the environment rather than domination, a recognition that survival in the desert requires working within nature's limits. Modern projects from Arizona to Oman are reviving these principles, combining ancient wisdom with solar-powered sensors to monitor water flow. As climate change turns more regions arid, these tunnels remind us that sometimes the most advanced solution is the one that's been buried in the sand for centuries. The Dust Bowl didn't just happen, it unfolded like a slow-motion train wreck, one that farmers watched with mounting horror as their fields turned to dust. Beginning in 1930, a combination of relentless drought and poor land management practices transformed America's Great Plains into a swirling wasteland. Skies turned black with topsoil, houses vanished under dunes of dirt, and families who had worked the land for generations packed up everything they owned and fled west. This wasn't just bad weather, it was ecological collapse on a scale the modern world had never seen. Yet if we peel back the layers, the Dust Bowl echoes disasters that toppled civilizations thousands of years earlier. Take the Anasazi we discussed earlier, abandoning their cliff dwellings after decades of drought. Like Dust Bowl farmers, they'd pushed their environment to the limit, clearing too much land, overplanting crops, and disrupting delicate water systems. Or consider the Garamontes, whose underground canals sustained them until overuse drained their aquifers. The parallels are uncanny. In the 1920s, farmers plowed up native grasses that had held the plains soil in place for millennia, lured by high wheat prices and the promise of new machinery. When the rain stopped, there was nothing left to stop the wind from carrying away the earth itself. The same short-sightedness that doomed ancient societies played out in the American heartland, only this time with tractors instead of bronze tools. But the Dust Bowl stands apart in one crucial way. We saw it coming. Unlike the Anasazi or the Garamontes, Dust Bowl farmers had access to weather reports, scientific journals, even government warnings about overplowing. Geologist John Wesley Powell had cautioned as early as 1878 that the plains were too arid for intensive farming without irrigation. Yet his warnings were ignored, just as the Sabaean kingdom likely dismissed early signs of their dams silting up. What makes the Dust Bowl so haunting isn't just the disaster itself, but how preventable it was. Photographs from the time show cars buried up to their roofs in drifts of soil, a surreal testament to human stubbornness in the face of nature's limits. The aftermath, though, holds a glimmer of hope. While ancient civilizations often collapsed when their environments failed, the Dust Bowl sparked one of history's most remarkable environmental turnarounds. The U.S. government established soil conservation programs, planted shelter belts of trees to break the wind, and taught farmers techniques like crop rotation to restore the land. Within 2 decades, much of the plains recovered a rare victory in humanity's struggle against desertification. Yet even this success came with a cost. The Ogallala Aquifer, tapped relentlessly for irrigation, is now being drained faster than rains can replenish it, setting the stage for a potential repeat. The Dust Bowl's real lesson isn't about the past, it's about the choices we're making right now. From California's Central Valley to Brazil's Cerrado, farmers are repeating the same mistakes, betting on short-term gains over long-term survival. Satellite images show dust storms in China and Africa growing larger each year, fueled by overgrazing and deforestation. The difference this time, we don't have the luxury of claiming ignorance. The Dust Bowl, like the ruins of Petra or the buried cities of the Indus Valley, stands as a monument to what happens when we assume the land will always forgive our mistakes. The question is whether we'll finally heed its warning. Cape Town's reservoirs sat nearly empty in 2018. Its 4 million residents rationed to 50 liters of water per day, enough for a 90-second shower and half a toilet flush. Meanwhile, in 2019, Chennai's pipes ran dry as monsoon rains failed, forcing hospitals to cancel surgeries and families to queue for hours at tanker trucks. These modern, day zero crises feel unprecedented, but history tells a different story. Look closer, and you'll find blueprints for survival etched into the ruins of civilizations that faced the same terrifying question: what happens when the taps run dry? Take Rajasthan stepwells, masterpieces of medieval engineering that turned scarcity into abundance. These weren't just holes in the ground, they were inverted temples, their staircases descending like fractal art to meet receding water tables. The Chand Baori, with its 3,500 steps arranged in perfect symmetry, collected every drop of monsoon rain in a reservoir so cool and deep it could sustain a city through years of drought. But the real genius lay in their design. Narrow openings minimized evaporation, while submerged levels stayed cooler, slowing bacterial growth. Communities treated them as sacred spaces, maintaining them through collective rituals that blended practicality with reverence. Compare that to today's leaking municipal systems, where up to 40% of urban water vanishes before reaching a tap. Ancient solutions are resurfacing in surprising ways. In Peru's Lima, one of the driest capitals on Earth, engineers are reviving pre-Incan Amunas systems of stone channels that divert fog drip from the Andes into natural aquifers. The technique, forgotten for centuries, now replenishes groundwater 3 times faster than modern wells. Meanwhile, in India's arid Bundelkhand region, farmers have resurrected chandelas, crescent-shaped earthworks that capture runoff exactly like the Nabateans did in Petra. Even California, where megadroughts strain reservoirs, is experimenting with spreading grounds, inspired by ancient Mesopotamian methods, flooding orchards in wet years to recharge underground stores. The lesson isn't just about technology, it's about mindset. Ancient societies viewed water as a common trust, not a commodity. In 12th century Morocco, the Agdal Gardens of Marrakech flourished under strict water-sharing laws enforced by community tribunals. Ottoman Istanbul's Sebil's ornate public fountains guaranteed free drinking water to all citizens, a radical idea in today's privatized utilities market. Contrast this with Cape Town's crisis, where wealthier neighborhoods drilled private boreholes, lowering the water table for everyone else. The ancients understood what we've forgotten. Survival in dry lands demands both innovation and equity. Yet some modern cities are listening. Barcelona now harvests stormwater in cisterns modeled after Roman impluviums, while Singapore's Eni water plants mimic the natural filtration of kanats with ultraviolet membranes. Even Las Vegas, that desert mirage of excess, has cut per capita water use by 40% through xeriscaping, a practice borrowed from the drought-tolerant gardens of Moorish Spain. These hybrids of old and new prove we don't need to reinvent the wheel, just remember how it turned. The ghosts of vanished civilizations whisper through every cracked reservoir and dry well. Their message isn't one of doom, but of possibility. From the stepwells of Rajasthan to the fog-catching nets of the Atacama, humanity has faced water crises before and thrived. The difference this time, we have their hard-won wisdom at our fingertips. The question is whether we'll heed it before our own cities join the ruins in the sand. Las Vegas sparkles like a mirage in the Mojave, its fountains dancing under desert sun while Dubai's skyscrapers pierce the Arabian dunes, monuments to humanity's defiance of nature. But these modern oases face a familiar reckoning. Just as Petra's Nabateans tapped every trickle from seasonal floods, today's desert cities rely on engineering marvels to sustain their impossible lushness. Vegas draws 90% of its water from the Colorado River, a lifeline now so strained that Lake Mead's infamous bathtub rings expose decades of decline. Dubai desalinates Persian Gulf seawater at staggering energy costs, while Phoenix's sprawling suburbs pump ancient groundwater faster than monsoons can replenish it. The question isn't whether these cities are impressive, it's whether they've learned from history's cautionary tales. Consider the Hohokam people who farmed Arizona's Salt River Valley 1,000 years ago. Their canal network rivaled modern Phoenix's in scale, diverting river water to fields of maize and cotton. For centuries, it worked until prolonged droughts coupled with overuse collapsed their system. Soil samples reveal a grim finale: salt crusts from irrigating with mineral-heavy water, poisoning the very land they depended on. Today, Phoenix's water managers face eerily similar challenges. The Central Arizona Project canals that bring Colorado River water resemble the Hohokam's channels, just with concrete linings instead of packed earth. And like their ancestors, they're gambling on a river that's shrinking faster than models predicted. Dubai's story mirrors another historical pattern: the illusion of infinite resources. The city's desalination plants produce half its drinking water, burning fossil fuels to do so, a modern echo of the Garamonte Civilization tunnels draining fossil aquifers. Both systems work brilliantly until the energy or water runs out. Satellite data shows Dubai's coastline sinking in places as groundwater extraction destabilizes the terrain, reminiscent of Venice's subsidence but turbocharged by desert conditions. Even the Palm Jumeirah's artificial islands, symbols of triumph over nature, face saltwater intrusion threatening their freshwater lenses. It's a high-stakes reenactment of Ubar's fate, where the very infrastructure designed to conquer the desert accelerated its undoing. What sets today's cities apart is their access to technology and their vulnerability to interconnected systems. Vegas has slashed per capita water use by 40% through xeriscaping and smart meters, proving adaptation is possible. But when a single cyber attack knocked out a Californian water plant in 2021, it exposed how reliant modern grids are on fragile digital networks. The Nabatean stone aqueducts never faced ransomware threats. Meanwhile, Phoenix's drought-proof wastewater recycling depends on energy-intensive treatment plants, creating a dangerous feedback loop as climate change strains power supplies. The ultimate test may come down to governance. Ancient Mesa Verde survived generations of drought through communal water sharing, while Timbuktu's decline began when political chaos disrupted maintenance of its systems. Today's desert megacities must balance competing demands: golf courses versus groundwater, tourism growth versus tribal water rights, short-term profits versus long-term survival. Las Vegas's ban on decorative grass in medians shows progress, but Colorado River states still lack enforceable agreements to prevent overuse. The ghosts of the Hohokam and Garamontes whisper a warning: no civilization outruns physics forever. The difference this time: we have satellites to track every disappearing reservoir, models to project shortfalls, and crucially, their ruins as proof of what happens when warnings go unheeded. From the ruins of Petra's water channels to the silent echoes of Timbuktu's dried-up wells, history whispers a warning we can no longer afford to ignore. Every buried city, every abandoned oasis tells the same story: civilizations don't collapse overnight. they unravel drop by disappearing drop. The Sahara's lost kingdoms, the Indus Valley's empty streets, the dust bowls choking skies, these aren't just relics of the past. They're mirrors reflecting our own precarious dance with water in a warming world. What's chilling isn't just how these societies fell, but how many saw the crisis coming. The Garamontes dug deeper as their aquifers dwindled. The Nabateans rationed water when the rains failed. The Hohokam watched salt poison their fields, yet kept farming until the land gave out. Their struggles weren't failures of knowledge, but of collective action. Sound familiar? Today, we've got satellites mapping every shrinking reservoir, models predicting droughts decades in advance, yet still, wells run dry and rivers choke on overuse. The difference this time, we're altering the climate itself, accelerating changes that once unfolded over centuries. But here's the hopeful twist. We're also the first civilization with the tools to rewrite this pattern. Ancient societies lacked global networks to share solutions, no way for the Maya to learn from Petra's cisterns, or the Sabaeans to adopt Qanat technology from Persia. We have no such excuse. From Peru's revived Amunas to Rajasthan's resurrected stepwells, the blueprints for survival are already here, etched in stone and memory. The question isn't whether we can adapt, but whether we'll choose to before the cost becomes irreversible. This isn't just about saving cities, it's about redefining what progress means. The ancients measured greatness in water temples and shared reservoirs. We chase endless growth in deserts, as if physics owed us an exception. Maybe the real lesson from these lost worlds isn't just about conservation, it's about humility. The desert doesn't care how tall our buildings are, only how wisely we drink. So let's keep unearthing these stories, not as obituaries, but as guideposts. Every like and share spreads these warnings further. Drop a comment with the desert secret that stuck with you. Was it the underground rivers beneath the Sahara, or the way Dubai's fate echoes Ubar's? And don't forget to subscribe. Our next adventure is already rising from the sands, ready to reveal how the past keeps shaping our future. The desert's secrets aren't done with us yet.